Let's look at final exam question number 28 in Physics Demystified, second edition. Please see page 519 if you have the printed edition. We're talking here, this is a difficult question. I'm going to come right out with that. This is an esoteric and difficult question, and you really have to have understood the material about radio wave propagation in order to get this one. Which of the following pairs of radio spectrum wave propagation modes produce effects so similar that we might confuse one for the other? Well, let's suppose we have two stations, two communications radio stations, say X and Y. And they're far enough apart on the Earth's surface so that no direct line of sight exists between them. Sometimes, at certain radio frequencies, notably radio frequencies around 50 to 200 megahertz, in that general range, we'll see a phenomenon called tropospheric bending, which is a form of refraction in which the radio waves can bend down towards the Earth because the index of refraction of the atmosphere is lower near the surface, rather higher near the surface, and goes down as we increase in altitude. It's a refraction process. We can also have an ionospheric layer called the E layer, which is considerably higher than the troposphere, say on the order of 50 to 70 miles up, something like that. And we can get sporadic reflection or refraction from this ionized layer. These ionized atoms are caused by radiation from the sun. The E layer is interesting because it tends to be finicky. We can easily mistake these two modes one for the other, and they both commonly occur in the FM broadcast band. Normally, you don't expect to hear a station more than 15 or 20 or 30 miles away in the FM broadcast band at 88 to 108 megahertz in the United States. But with either of these two modes, certain kinds of atmospheric conditions, certain types of ionospheric conditions can produce propagation over hundreds of miles. So you might live in Michigan and hear a station in Mississippi because of either of these two modes of propagation. It's very interesting, and one can mimic the other, and it can be difficult sometimes to tell them apart. The correct choice for this particular question, therefore, is D. I know this is a difficult question. The best I can recommend for you is that you go back in the book and review the material on radio wave propagation, and if you're a short wave listener or a ham radio operator or are interested in those hobbies, you'll know it right away because this stuff will fascinate you. But again, D is the answer here.